First of a two-part series. This video will introduce the perception algorithm, and in the second video we'll apply it to something concrete like the weather. So the first thing we'd like to do is take a look at the components of the algorithm. And this is something you can do for yourself. You can change these if you'd like. But basically the concept is you have some initial value. In this case it's a forecast. You're going to subtract something away from it that's wrong. In this case it's a forecast error. Then you'll add some information that's hopefully objective. We're looking for evidence. In this case, we look up at the sky and we see, does the sky agree with the forecast or not? And then finally, our result, the name of that happens to be degree of forecast belief. You can name that anything you want. These are configurable. The basic idea is that the first two items are about subjective information. Usually it's measured on an intensity level because they're generally feelings. And what we're trying to do is balance that with some kind of evidence. And that's how we get this equation. All of the items are configurable. So for example, for forecast, you can see the emoji and the labels we've given each rating. And then forecast error is the same thing. You can change these to fit your situation. You just press the edit button. And then for evidence, here we have a range. And what we're really saying is, in general, if it's objective, we want to go from something that's totally false to something that's totally true. And you can change these same thing, press the edit button. You can change the emoji or the labels. And finally, here are the, it's the same thing. You can associate different emoji and names with the different variables. And the key thing is that it ranges from -3 to +3. That you cannot change. But what's the information associated with those variables, you can change. So let's take a look at one that's not specific to a forecast. This is the default. And the first two subjective items are perceived truth and perceived fallacy. And what we're trying to do is counterbalance that with something objective like evidence. And this is the default perception algorithm name. It's called degree of belief. That's what we're trying to balance. We're trying to balance basically our feelings with something that's objective. Hopefully it's evidence. Now let me show you an example where you don't want to use evidence because it would not represent the situation properly. If you're familiar with the fox and grapes example or Aesop's fable, you'll notice that the fox just didn't pay attention to the warning signs. And basically that's called a bias. In this case, it's a confirmation bias. He just wanted information that supported the fact that he could get the grapes. Any indication that he would be unable to get the grapes is something that he ignored. So there are four basic causes of biases, of cognitive biases. Information overload. Let's go back here. Information overload, which means if someone is telling you too much, you just shut down. Insufficient meaning basically means that if you're not talking to someone about something they care about, they're not going to pay attention. In this case, the fox suffered from a need for quick action. All he wanted to do is get those grapes as fast as possible and wouldn't listen to anything that contrary to that or accept any kind of new information. When he was jumping and he couldn't reach it, that didn't deter him from trying to jump higher. And then memory is another source of cognitive bias. So let's take a look at the need for quick action. Now, what we did differently with this algorithm is we changed the confirmation bias. And actually, I meant to say we replaced evidence with confirmation bias. Normally, this would be evidence. But it's inappropriate in this case because the fox would not pay attention to any kind of evidence. So here we've got two subjective items, but we also have a third one, and so that's important to realize that people don't always use evidence. Most of the times they do the opposite. So I wanted to limit these to about 5 to 10 minutes. And the next video will explain how you can use this compare feature to automatically, let's select one here. You can use this compare feature to automatically tell you what the best decision is using the perception algorithm, but that takes some explaining, so it'll be explained in the next video.